This is lesson 9.2C, the third video in college trigonometry dealing with logarithmic functions. The first couple videos were just kind of introducing logarithms and mostly teaching you how to go back and forth between a logarithmic function and an exponential function. And if you remember, exponents and logarithms are the same thing. Using a logarithm is just a simple way in order for you to solve the variable x when it's in the exponent position. So, for example, just again, when you have something like that, using logarithms is a way for you to find out what that x is by writing this is log 3, 9 equals x. Okay, so it's just another way of writing your exponent, because what you're doing is you're using this in order to find your exponent. Alright, so in the first couple videos we were talking about switching back and forth between logarithmic and exponential forms. We also were talking about how to graph. I would really highly suggest, because I feel like I kind of went a little bit fast through the graphing logarithmic functions, is to really pay attention to the top of page 406, those first four characteristics they give you, and what it takes to translate a graph up or down and left or right. And I would really suggest those of you that haven't had a lot of experience with logarithms to do some searching on the internet. Maybe go and look up in YouTube videos some things on logarithmic functions, because most people that are in this class have already done things with logarithms, and this is just review, and so that's why I'm going fast. But if you have not had much experience with logarithms, it'd be good for you to get some review, because there is some good review stuff out there. Alright, so in this section, 9.2c, we're going to talk about properties of logarithms, and this might be enough to get you through the logarithmic process if you haven't had much work with logarithms. Now, when we have two variables with exponents, and you're going to multiply those, remember, you add the exponents. And if you have them written this way, use what's called the power rule, and then when there's no sign between them except a parenthesis, that's kind of your cue to multiply the exponents. In fact, I should probably write that as 2 times 3. And if you have an x squared over x cubed, remember what we do here? We subtract 2 minus 3. And if we have logarithms, they are the same as exponents, so the same thing happens. So if we have, and let me move this out of the way a little bit, if we have a log with a base a of one variable times another, that is going to equal, the bases will be the same all the time. It will equal that. So notice, exponents multiplied, when you put them together you add them. So you're going to want to know how to go back and forth from this to this and from this back to that. That's going to be very important for you to be able to do that, because it's going to help you solve some of the problems. Now, if you've had college algebra, you've done some logarithms a lot harder than what this course is going to ask you to do. So hopefully it won't be any problem. When we have log a of x over y, that is going to be the same, and again, that's a division problem, so we're going to subtract my x and y. Okay, and then we've got a power property, x to the r power. That means we're going to take the r and we're just going to put it in front of the logarithm and get that. Okay, so that's just some ways to move back and forth. Okay, so nothing really hard to learn there, but there is another additional property that you need to write down besides the product, quotient, and power, and that is the log with a base a of 1 equals 0. Now let's change that to exponential form. That would be a to the 0 power equals 1. And you know that's a true statement. And that's how you would write that. Also, log a, and I like to write these as exponential so that you can say, oh, I get that. I understand why that works. I understand why this is true because I know that. So let's write this bottom one in exponential form. A to the first power equals a. Well, I know that's a true statement. Any number to the first power is itself. And that's just the way to write that in logarithmic form. So put those two down. Let's do some examples here. And we're probably going to do, 10 or 12 different examples of switching back and forth and solving. So it might take a couple more videos to get through that. So let's go ahead and get started with that. So the first 4 examples in the main example 4 should be pretty easy, but as we get down into some of the other ones like F, it gets a little bit trickier. So let's look at one simple. Log with a base of 6, and we have 7 times 9. And so that means we're just going to split those up. And it's going to look like that. They're not asking you to solve it. They're not asking you to do anything. In fact, at this point, you should not be able to solve it. All right, B is going to be the same thing, only you're going to take 15 minus 7 instead of like we did the 7 plus the 9, because it's division. And C is starting to get where it gets a little bit trickier. Log 5, square root of 8. Alright, what I suggest doing is changing your square root of 8 to an exponent. So it just makes life easier. So we'll make it 8 to the 1. Oops. We'll make it, 8 to the, well, why did I put a third there? 8 to the 1/2 power. Okay, when you do that, you take this and put it in front. And you get that. Okay? So, not much to that. We're just rewriting it. And let's look at D. D says the log of A. Boy, they make those bases very tiny. I can hardly even see them. MNQ over P squared. Alright, so with D, there's a little bit of work involved here. And again, you're going to work with the top and then you're going to work with the bottom. So the MNQ, I'm going to have to write this on the bottom because it's going to be a little bit long. M plus N plus log A Q. And then this P squared is on the bottom, so it's going to be minus. And then we have this 2 here, so that 2 actually can go in front of there and we can get rid of it there. So we've kind of done 2 little tricks there at the same time. And that's your answer, that whole big long honking thing. Alright, so let's look at E here. And E says we've got, again, if I can read that tiny print, log base A and cubed root of m squared. And again, what I like to do, and it looks like the book's doing the same thing, is get rid of my radical sign. So that's all I'm going to do here. And that'll be 2/3. Because remember, the index goes on the bottom, the exponent goes on the top. And then I can just take that and move it in front, and I'm done. 2/3 log A M. Alright, one of the things that I want to make you aware of that's very, very important, and I'm going to be a stickler with this, is oftentimes when you're writing, you get in a real big hurry and you don't write this correctly. Meaning, sometimes I'll get assignments or tests that you've gotten this, and then you'll do this, and you really mean for this A to be in the down here is a subscript, but because you're in a hurry, you write it like that, and it looks like it's A times N, M, instead of that A being a base. You need to make it a priority to write it the correct way, because if you're writing it incorrectly and you put it on a test, I will take points off because you're not taking the time to be accurate in your math, and that's very, very important in math, and you will find out if you take calculus how important these little details are. Alright, so let's do this last one, f log b nth root. So just write slow. That's probably the big thing. You know, and I say that, and I'll probably make some mistakes and make it look like it's not supposed to be that way too, and slap me for that. Okay, so let's go ahead and change that to the nth power. So let's go ahead and make everything the same. I'm going to change the thickness of my pen so that I can make these things smaller, and then whoa, that's not what I wanted, is it? Alright, let's make it thinner. Alright, there we go. And that will be then to the 1 over n power. Yeah, see how nice and thin that is. Alright, so now I'm in that position. The first thing I'm going to do is get rid of that. So that's going to go on the end, in the beginning. And then that'll be x cubed y to the 5th over z to the m. Don't forget your parentheses there. Okay. Now what I'm going to do is I'm going to split those up with that. So I'm going to do it in one fell swoop. I don't know if I like this real thin or not, but I can write smaller. In fact, what I'm going to have to do is I'm going to have to put a parenthesis, because this 1 over n is multiplied by that whole thing. So log base b of x cubed. See how this looks. I've got a subscript, I've got a variable, and then I've got an exponent. So 3 different layers there. So you got to make sure that it's obvious what you're doing. So I've got that, and then I'm going to write log base b y to the 5th minus log base b z to the m. Okay, so see how I did the subtraction there in order to make sure that was right. Alright, so what do I do with that? Alright, I'm going to take each exponent and put it in front. So again, it just, you know, it kind of goes on and on. Whoops. These are not doing what I said I was going to do. I'm going to put the 3 there. Base b of x plus 5 log base b of y minus m log base b of z. Alright, so I'm getting more and more of this spread out, I guess you could say. Now the only other thing for me to do, since these are all simplified, is to distribute that. So I'm going to distribute that, and I'm going to get 3 over n log base b of x plus, and I'm distributing it, 5 over n log base b of y minus m over n log base b of z. That is supposedly that simplified. Okay? So that's it for video 9.2c.